Thank you. So welcome everyone. Have you had pizza? And still get up and eat and watch me. You'll enjoy the pizza more than you'll enjoy me. So are you all .NET developers? No? Who's did I say something rude? Okay, who's .NET? Who's Java? Cool. Who's a Kotlin developer? Okay. So, where is Andre gone? Who paid for the pizzas? Andre, who paid for the pizzas?
Who paid for the pizza?
Yeah.
Me.
Wow, thank you.
You're welcome.
Okay, cool. Right, so good news. This is not in C# and it's not in Java. But since you're in JetBrains, you're going to have to eat pizza and eat Kotlin. So my code examples are going to be in Kotlin. But it's not, I'm not doing subliminal advertising, because if I were, I wouldn't tell you this, right? I'm forcing Kotlin down your throats. Hopefully you'll enjoy it. No, but in all seriousness, it's it's the stuff that I've been doing lately. So my code is mostly in Kotlin. I'm a C# developer. So I hated Java, and I never went to Java because of Java, the language. Now I like the language, so I like the JVM. I also do JavaScript, but I don't want to publicly admit it because I hate the bloody thing. So anyway, right, enough about me. So welcome to this talk about embracing HTTP in the era of REST APIs, or as I like to call it, enough with the REST bullshit. Because I'm really sick and tired of REST. How many of you do REST? Okay, great. So I found that normally REST is pretty URLs returning JSON, which it is not. But there's a lot of blog posts around pretty URLs returning JSON saying that that's what REST is. So hopefully I will demystify REST in the process as well and tell you that what you think is REST, well, I don't know what you think is REST, but maybe it's not what you think REST might be, or maybe it is what you might not think it is to be. I'm just trying to make it very confusing for you. Okay, so, and by the way, everybody kind of speaks English, yes? Yes, okay. And if I'm talking too fast, I'm sorry, I can't do anything about it. Right, I'll make a very bold statement. With HTTP, your API is your application. So that basically means that you have a single API, and that's your application, and that's what you're going to be consuming. I'll go very fast on these parts. Basically what I'm saying is that in the past we used to have two interfaces, right? We used to have a user interface where we created the web application. So if you're in Java, maybe you were using Java server pages or Java server faces, and if you're in MVC, you were using something like ASP.NET MVC, or if you were unfortunate, you were using something like web forms. And then you had the other aspect, which was the API. So one thing that the user could do, and then another thing that your developers or someone from some other company could interact with your system. And that's how you created web applications. Yes or no? Yes, good. You have to agree with everything I say, otherwise it just doesn't make sense. How many of you actually are web developers?
Sometimes this interface is the same.
Sometimes it's the same. That's what I'm getting to. But wait, because there's two more slides. That's where I get to. You spoiled it for me. Okay, no more. I'm joking. I'm very sarcastic. Just ignore me. So the advantages were that it's easy, right? You create an application, and in essence, there was no real other way to kind of do this, because if you were doing like web forms, it was really hard to do anything else. The disadvantages is that you had two systems to maintain. You had your website with your web interface, and then you had your API. And a lot of times what would happen is someone would say, can I do this via the API? And you would say no. Why? Because it was an afterthought, right? It was always kind of like, yes, now let's start to provide all this functionality via the API. It also provided kind of limitations of the API. The idea here is just to do a simple interface. You see what I'm saying? Now you said my slide. So one API, and that API is the same that you use for your user interface, and it's the same that you use for your web application, right? And your API. And so that's it. That's what I mean by your HTTP endpoint is your web application. So why now? Well, one interface, I obviously don't mean that you have the same interface. It's just kind of following the same API calls. Why can you do this now with a single interface? The advantage is, first of all, is that you have a single interface, so you don't have two systems to maintain, right? It's a single system, and the API is designed from the get-go, because basically that means that if I can do it with my web interface, then I can do it with the API. So anything I can do with my web interface, I should be able to do with my API. So then you don't run into the issue of someone saying, can you add this functionality to the API? No, because it's already there. I've already done it. The disadvantage is that the API is designed from the get-go. But that's an issue with everything, right? If you're just a single consumer of something, you're going to have that issue. So really, that isn't a disadvantage. Why is it possible, and why is it possible now? Well, first of all, frameworks have evolved, right? We're no more pushing, like there is no more this idea of constantly having everything generated on the server side. Now we're starting to do things on the client side. How many of you do client-side development using something like AngularJS or React.js or the flavor of the month that is this month? I think this month it's Cycle.js. Next month it'll be Meteor.js. So that has evolved. Unfortunately for us, as I said, JavaScript has become a viable language. Hopefully it will die eventually, but not today. So that enables us to do certain things now from the client side. And the other thing, that HTTP has been undervalued. Really, we haven't thought about HTTP for all the value that it has. We've just kind of thought about it as something that allows us to communicate across the web. And the most important thing, REST is a buzzword, right? Nobody in their right mind starts an application today or starts a startup that doesn't have a REST API. Everybody has a REST API. Everybody, right? Do you guys have REST APIs? Yes. You got to work with me here, people. HTTP application protocol. Now, here is the OSI layers. How many of you remember the ISO of the OSIs? Or the OSO of the ISIs? 7. How many does the internet have?
4.
No. 3 or 4, or 5 or 6 or 7, right? It has 5. Anyway, so on this, where do you think HTTP sits? Come on, say it. Say it out loud. It's okay. Green. Green presentation. Who says transport? Who says presentation? Application. Right? Yes, because I said it in the slide before. Right? Remember? Application protocol. So that's good. That means you're reading my slides, which is fantastic. So yes, it sits on the application layer, but the majority of times we're treating HTTP as transport layer, not as application. We're just using it to interchange messages without actually leveraging everything that the application level has. So let's try and focus a little bit on that. HTTP 101, it's very simple. You make a request, you get some headers, you get some response, you get some headers. Everyone familiar with that? Right. Headers were introduced back in what version of HTTP? 1.0. 0.9 didn't have headers. And then they said, let's introduce headers, and then everything went downhill from there. And then 1.1 created more mess for us. But it's okay, because 2.0 is going to save us. It is, really it is. Here is a typical URL. Post domain.com app services. Response, 200 OK. Now, can anybody tell me what's wrong with that? I'm going to make this as interactive as possible. What's wrong with it? Good point, XML. Apart from that. Well, yeah. It's what? I passed the post in the... I passed the host in the header. What host? No, that's irrelevant. I'm just posting to a URL. That's a URL.
You can use URL params instead of...
I can use URL parameters, so okay, you're saying I could do a query instead of a post. Yeah. But no, there's something else wrong with that.
It looks like you're executing code.
No.
You're returning single number.
Wow, there's like a hell of a lot wrong with that. Can someone tell me the font color is bad as well, please? Okay, so yes, first of all, the most important you pointed out, it's XML. So it's not RESTful because it's not JSON. That's a joke. But if you look at it, what I'm basically doing, I'm going to post domain.com app services, right? And then I am calling a method which is method name calculate age, passing in some parameters, and then I'm getting a response, which is giving me the name of the parameter, the result that I'm getting back, and the actual value. What is this? This is what? Remote procedure call, web services, right? That's what it is. It's just a single endpoint that I am calling. And I'm putting basically all the information in the XML. So already I'm losing a lot of value because I'm not leveraging some of the things that HTTP gives me, right? Let's try and improve on that because we can do it better. Let's try and start with multiple endpoints. Now we move from a RPC, remote procedure call, to something else which is not SOAP, which isn't basically encapsulating everything into an XML file. And I'm going to domain.com, calculate age, response 200 OK, and then I'm doing domain.com get customers. Notice there's a post there. It's OK. It could be a get, but it's a post. And I'm returning 200 OK customers. Now, what have we improved there? What have we changed there? First of all, we've gotten rid of the XML part on the server side. So we're no longer encapsulating any of the method names inside the actual package that we're sending over. We're starting to push those method names to the URL, okay? So now we're leveraging something, not much, but we're leveraging something. We're going from from a single endpoint to multiple endpoints. But it's still very, very cumbersome. And every time I change something, what happens is that I have to update that XML definition, right? Let's do a little bit better. Let's look at a typical CRUD application. What do you do in CRUD? You create stuff, you read stuff, you update stuff, you delete stuff. Yes? We've all done that. 99% of the applications we write are CRUD. We just like to say it's domain driven to make us look smart, right? But the majority are CRUD. Now, if you look at that, and please, do you see this little star here that says don't take this literally? Remember that before you start to criticize me, because that means something. Well, you can always criticize me, it doesn't matter. So create, let's say that that's post, read is get, update is put, and delete is delete. If we align those HTTP verbs with actual typical CRUD applications, what can we start to do? We can leverage also verbs, right? So now we can move to get domain.com/customer/1, returning 200 OK. So now instead of a post, I'm leveraging a get. I'm saying this is a get. Post domain.com/customer, 200 OK. So I've moved away from an RPC with SOAP definition. How many of you are familiar with WSDL? Web Services Description Language, where you had to have this really awesomely long thing that you would import and then know what to call, to something a little bit more discoverable, right? And that's the key thing here. It's discoverable. Because now I have just verbs that I can use. But there's something different also here. Can someone tell me?
Resources. They're already resources.
They're already resources. Who's saying that? Okay. So we moved away from verbs. Right? We've moved away from actions, which are calculate age, to a resource. So we introduced the concept of resource. So now we have customer, and then we have customer, and notice that based on the different types of verbs, I can call it differently. Now there's something else wrong here. Can somebody tell me what's wrong there? Response code on the post. On the post. The response code on the post, we normally send back 200, but it should be normally 201, right? 201 means created. That's what we should be sending back. Okay? If it creates a resource. So, let's skip that, because I'll show that later. Okay, so now we have this client side. So the problem is that if I'm calling this from an API perspective, if I'm calling this from a jQuery, or well, not jQuery, from a Java application, it's fine because I can have an HTTP client that does get, put, post, delete, all of these verbs. However, in the browser, those verbs aren't available. And if we're saying that we have to have a single API for our user interface and for our API calls, how do we leverage that? Well, we can use jQuery, we can use hidden fields. A very common technique is to use a hidden field that tells us the exact verb, and then always send it as a post, and then have the server side filter that out. Or if you're using something like jQuery, which again, that's not fashionable anymore, but whatever is fashionable these days, then you can just execute the exact verb. You can also use X HTTP method override. X, do you use that header, which is adding an extra header? No, and you shouldn't, because X was never for extra headers. X was for experimental. And someone just said, well, let's just call it extensions. So we're extending. But X was really just used for experimental. So you can actually add your own thing. But people now use X HTTP method override, saying that when I'm making the request from the browser, I'm overriding the actual method. The server side, you would parse that, get the actual verb, and apply the action. Now, sometimes what happens is that you don't want all actions to have specific effects. So let's say that I have a customer resource. So I have a bunch of customers, and I don't want to allow some action to be executed on some resource. How would I do that? How would you do that in HTTP? Don't have a specific verb. So that would be one option. So let's say that I have, on the server side, I have a resource customer, and on the client, the API call does a delete customer 1, right? If I don't implement that on the server side, what happens if for some customers, for example, I do want to provide that support?
So you're talking about the possibility to know all available methods or not?
I'm talking about if I don't want to execute a specific verb on a specific resource. How would I do it?
Return error code.
Return error code. Okay. So, but here's the thing. What error code would you return? 44? 403 forbidden. Okay. So that's good. But here's one thing that we want to try and do. I want to move away from WSDL. Right? I want to move away from XML. Why do I want to move away from XML? Because XML is not discoverable. Let's keep this in mind all along this talk. I want to make my API as discoverable as possible so that I don't have to ever provide a WSDL. Right? So, if I want to, for example, allow someone to know that I have customer, and this customer has specific actions that can be applied to them, how would I be able to do that? HTTP, pardon?
Hypermedia API, navigatable.
Well, we'll get to that. But first thing that you do is there's a header that says allowed verbs, right? So when you execute, for example, a put, the HTTP application can respond and say, allow verbs, get, post, right? But put is not allowed. So already you're providing a discoverable step. You're saying that on this specific resource, I can execute these verbs, okay? And that's different from a 403, which is because a 403 is saying I can execute this, but I just might not have permission to execute this. So it's different, okay? Now, what happens is that a lot of times, if I'm implementing this on the server side, how would I do this in a practical way, right? Let's say that, for example, you're doing, I don't know, what is the typical Java technology that you have for server-side stuff? Spring, right? Spring allows you to define all these different verbs and say, I have this controller, and this controller has get, put, post, delete, all of these things. In order to implement this in a practical way, what you need to do is kind of try and automate this. So that if I call, for instance, get customer and get isn't allowed, I don't have to manually manage this. So a lot of the technologies have these things called middleware. Have you heard of the term middleware? Like Node.js has middleware, or ASP.NET MVC has filters, or some other technologies have interceptors. And the most convenient way to do this is basically to scan your routing table. From the routing table, figure out what verbs are allowed and not allowed, and then based on that, return certain values. Okay? Let me show you a little bit of code for that. Is everyone following me? No, but it's okay. It's fun, right? No, do you have any questions? No? Great. Can you actually see anything?
No. No.
Okay. I don't like presentation mode. Really, it's yeah. Is Kostya here? I shouldn't say that in public. Okay. So let's see. Auto. So basically, like, okay, I'll make it a little bit bigger for you, just because I'm trying to be really nice tonight. Let's make that 30. 25. Okay, good. Right, that's good, right? So basically what I do here is, this is kind of middleware, interceptor, filter, what have you. And what I'm doing is I'm scanning my routing table, seeing, for example, what controllers I have defined, etc. And then based on those, creating an allow header. So basically all you do is you send back an HTTP header, which is allow, and then it concatenates all the verbs that are allowed, right? And then you send back a status code of OK. So what this does is when the user gets, when the API call gets that, it says, OK, I get an allowed, not a status code, OK. That's actually a bug. It should be method not allowed. Method not allowed. So it says, these are the allowed methods, get, post, but put and delete aren't allowed, so you have to do it again. What is the main purpose of this? It's to leverage HTTP status code and HTTP headers to tell the user what to do next. It's about creating this discoverability each time, right? Not having them look at an API documentation which is outdated to tell them what they can and can't do. Okay, because we also know we never keep API documentations. Next, creating resources and location header. Here's a typical thing that could happen, right? I create a new customer. How do I get back that information? Let's say that I create a customer with an ID. How do I get back that 20? How do I know that that 20 or that 2 is the ID that the database has generated for that customer? How would I do that? I could, of course, include it inside here as a response. So let's say I have a response and I create a customer and I say the customer name is, confirmed and the ID is 2. But there's actually a header in HTTP which is called location, which is precisely for this thing. What location does is give you back the location, the URL of the newly created resource, right? So when I do a put, what I can do is add a location header with the actual URL of the newly created resource. How many of you use location headers? There you go. So now start using it, okay? You promise me?
Yeah.
Good. That is really it. That is exactly what the HTTP application RFC defines. Return the location of the newly created resource in response to a post. This is good because now what happens is that when I create a resource, I immediately, if it's successful, if I get a 201, again, you see there's a bug there, it's on purpose. When I get a 201, I can look at the location header and say, okay, this is the newly created resource. So now I'm discoverable. Now I know where I can go next. Next,
Use content type here.
why do I use content type?
Because of the empty answer. So application XML is just we really need it or what?
Well, I mean, this is, maybe there is an answer, I didn't put the result here, right? But if there was, that's just a header that's there, right? If there isn't a body, then yeah. But that's just a header that was there, right? I'm not returning the actual body on this slide, okay? So now, errors. This is the majority of web applications or HTTP APIs. If everything is okay, I'll return a 200. If something goes wrong, I'll return a 500. It's basically the exact same thing as let me surround all my code with try, catch, exception, right? If something goes wrong, screw it. I'll either swallow it or I'll just capture every possible exception in the world. How many of you use 500? You should really not use 500 unless really, excuse my English, the shit hits the fan, right? That is, I've been told that in Russia, you're not really accustomed to people using foul languages in presentations. I'm sorry, I'm not Russian. I don't know what I am, but that's a whole nother story. So anyway, that's a lot of things, but HTTP has a lot of status codes that aren't leveraged. And I'll tell you an example that just came up here recently at JetBrains. Here are the status codes of HTTP. 200 means OK, which is basically what everyone uses all the time, and you shouldn't. 201 is when you create a new resource. What's 202? How many of you use 202? Async operations. Once. So let's say, for example, I create a resource that takes a long time, right, to create. It's an async operation. What you can do is you send back a 202 with a location header that will then define the polling, where you have to poll to see if the resource has been created, right? And once that resource has been created, then that one is the one that returns the actual status code. 301, move permanently. 302, found, whatever. Bad request, unauthorized, forbidden. So here's an example. We have a product called here, and this actually happens on GitHub as well. We have a product called UpSource, right? If you go to a URL or a project in which you do not have access, it returns a 404. GitHub does this as well. That's security through obfuscation, basically, right? And it shouldn't, because if it tells me a 403, I know what I have to do next. I have to go to the IT department and say, give me permission, right? But if it's returning a 404, I'm looking like an idiot. Am I typing the URL wrong? Really, like, am I stupid or something? Right? Why not use the correct HTTP? Cool. Right? That's kind of like, you know, creating a login page, putting in your username and your password, and then if you don't have permission, suddenly it just crashes your browser, or just it says no, not found, or everything disappears. Right? Use status codes for what they are. If you don't have permission, use 403. If you're not authorized, that means that I need to log into that resource. Use 401. Why? Because then you're telling me the next step. You're trying to make it discoverable for me. Okay? 404, not found. 405, which we saw, which is method not allowed. And this is good for this thing, control flow. And I'll tell you why in a little bit. Okay? 409, conflict. Let's say that I'm creating a database record and at the same time someone else is updating it. And then I push my updates and I see that there's a change since the last time I updated it. Return a 409. Now, this is also good for something else because it's like semicolons in JavaScript. You can end in eternal discussions on Hacker News on which status code to use, right? So a lot of times it really depends on your scenario. Should I return a 404 or should I return a 403? It kind of depends, right? Although in that case, you should never do that. So just ignore what I just said. Now, let's talk interfaces. How many of you use Checklist? You should, all of you. No, really, it's really good and it's free. It's a to-do list by one of my colleagues, Kirill, that also does Team City. But it's really, really nice, and there's a free version as well. And we all love free, right? We call it open source, but it's free, what we love. I got to remember to be politically correct. I keep forgetting. Right, so anyway, that is checklist. And if you look at the URL, look at the URL up there. So it's checklist 4040751. Now, look at this one. That's the exact same URL, right? But it's different in the term of response that it's returning. One of them is returning XML, the other one is returning JSON, this one is actually returning a UI, right? But it's the exact same resource, exactly the same resource. And that is what we call resource representation. So each resource can be represented by different ways. I can have customer 10 that could be an XML, there can be a web page with the XML nicely displayed with some labels, it could be a picture. A resource can have multiple representations. And HTTP has support for that multiple representations via a header called content type and a header at the bottom which is called accept, right? So you also know what accept is, right? Everyone is, you know, text / HTML. That means I accept anything that's text HTML. What's the Q here? How many know what the Q is? Priority, yes, it's the weight. basically. So by default 1.0. What this basically means is that application XML has more weight than text HTML. So it's not the order in which you put them, but the queue that's following. And why that is important is because this thing goes on which is called content negotiation, right? So when a server makes when a client makes a request to the client says, I accept text HTML, I accept application XML. The server now takes that, orders them, weighs them, and says, okay, which one can I serve? I can serve application XML. Here you go. I don't have that. I can serve text HTML. Here you go. And if I don't have any of those, then content media type not supported, which is a status code of HTTP. But this is important because it's not just always asking for the same thing. It's asking to negotiate the different levels. And how do I call this? So there is no right way. There is no RESTful way to do this, right? You can call it with customer25.json. The great thing about this is that you can actually call it from a browser. Otherwise, you tell me how I could get a JSON representation in a browser without using Chrome tools to hack the headers. Or you can use article.es. What's ES? It's a different representation, except in this case, it's talking about the language. So I can have a single resource, which is, for example, the latest news article in English and in German and in Russian and in Spanish. You could also use query parameters. So really, there is no correct right or wrong way. The good thing about it here, the important thing to note, that you have to have support for content negotiation. So not many application frameworks have this, right? A lot of them are basically very simple. You want to send back, application/JPEG? That's all I got. If they send me text HTML/application XML/application JSON, I don't care. I'm just going to look at the one I have and send back and not do anything else. Ideally, your application server, whatever you're using on the API, Spring, MVC, whatever, should have support for this. If any of you, how many of you using .NET? Again, if you're using .NET, there's a really great framework out there which is called NancyFX, right? Which is how you should do things, not how Microsoft tries and copy. Okay, so NancyFX has proper content negotiation. I have samples of how to implement this in a framework that I've got on GitHub as well, which is mostly has gone to demo purposes, which is content negotiation, right? So this is basically an interceptor that is giving me back. Why is that giving me this? Basically, what this does is, ideally, frameworks should automate this for you, right? A lot of the things that I show can become cumbersome. So you need to do a framework, use a framework that automates this. If the framework doesn't automate this, you do it yourself. You automate it the first time so you don't have to deal with it. Here, what I've created is basically a content negotiation interceptor. And what it does, it intercepts the headers. It tries to find what type of request is being made, finds the correct serializer for that content type being requested, serializes it in that format, and sends it back. Okay, and if it can't find something, it will say unsupported media type. All of this leads you to create HTTPIs that are very discoverable. But in order to do this, it requires a lot of manual work to handle all of these cases. As soon as you start to do that manual work, you're like, screw this, I'm just going to do an API and I'll call it REST. Right? That's why you need to use a framework or something that allows you to automate this stuff. Next, single entry, well, that's auto negotiation. Okay, performance and reliability.
Can I
yes.
ask a question? When you're talking about HTTP status and about error codes, I remember my general question. What is the best way to pass error messages, user-friendly error messages to client? What is the best way? What do you think?
What is the best way?
Best way.
But to what client? To
Yes, to end user.
End user.
Mm-hmm.
Okay, but but that's through the user interface, right?
To show an user interface and processing it and.
Okay, so that's where I say that you can have endless debates on which status codes to use. right? There are certain rule of thumb for me is the following, okay? If you can use a status code that has semantic meaning in HTTP that allows the next step to be discoverable, use that status code, right?
Okay.
Does that make sense? No.
Not all times.
Not all times you can encapsulate an error inside it. Therefore, the next step is you need to decide what you can do, right? And that very much depends on your application, on your context, on your users, on who's consuming it. There is no right or wrong way.
Sometimes I made custom error codes, 10,000 and all, and increment it and have a dictionary to match past error ID and error message on each client with each localization. And I think it's a wrong way to make good application.
There's limited status codes that all of them are not going to encapsulate your logic.
It's
Okay. So, who's got a better answer than a consultant? Like a consultant always says it depends, right? What?
I saw a system when the error was a resource also. So when the error status code was sent back to the client, there was a allocation header to the error, and error was a persistent resource which you can discover and which you can look at, and which you can ask questions.
Right, but what happens if the error code that you're trying to return falls outside of those HTTP status codes? Do you return a 200 or do you return a 500?
No, not the 500. The rule of thumb for me, the 4xx is the client lane and 5xx is the server lane. If you don't have a specific error code, you use the general error code as in recommendations.
What if you want to tell to user about one of any field he entered in UI is wrong or validation error?
Yeah, but that's surfacing at a different level. That's like at the user interface level, right? So
I want to understand what should I to read to understand what is the best way for general, not a custom way, no, by default way.
okay, let's address this later. Okay?
Okay.
Okay. Because yeah, it goes a little bit off topic here. Okay? And we're gonna making things reliable, right? Safe and idempotent. Okay? So there's a difference between safe and idempotent. Options is idempotent and it's safe. Get is yes, safe and idempotent. Head is safe and idempotent. Put is idempotent and safe. Brilliant. I know how to read very well, right? Based on that, do you know what idempotent means and what safe means?
Not really.
Right. Idempotent means?
Repeat operation is don't change data system.
Okay, so what does safe mean?
No idea.
The first request does not fire some bomb.
No, okay, think about it. Get and get. What happens when I do a get? I always do the same thing, right? If I do multiple gets, what happens? I get the same thing, right? So what about if I do, for example, so here we have, for instance, a put. Put says that it's idempotent, but it's not safe. So what does that mean? That it impacts the system, right? So therefore it's not safe. So that means that if I do two puts, it's not safe. But if I do two puts, it is idempotent. That's just like crazy talk, right?
Non-new objects creation.
It's doing the same exact thing, right? But it's not safe because it is impacting the system. And the reason for this is very simple. We have between the client and the server thousands of different things which are called proxy servers, caches, all of these things. And the network, as you know, is not reliable, right? If we take these table into account, if we design our APIs so that a get is safe and idempotent, a put is idempotent and not safe, then we know that basically we can follow the whole architecture of the World Wide Web. And if I do a call to a proxy, the proxy interprets a get, and it knows that if I do a get a second time, it's going to be okay. It's always going to return the same result. It's kind of like the same as command and query separation, right? You should never have a method that does returns a value and alters the state of the system, right? This is basically the same kind of concept. Why? This is nothing more than just a constraint. If we take these constraints into account, now we can start to use and leverage some of the things that the network offers us. Okay? We'll get to that. Caching is built in, right? So you can cache things. Max age tells me how many seconds I can actually cache a result. Expires tells me on a specific date when something expires. Conditional gets or e-tags. How many of you use conditional gets? Let's say that I make, for example, a request to a server, right? And the request to a server brings me back a really long customer, or brings me back an invoice with a lot of details on that invoice. Let's say that that invoice doesn't change. If I make another request, it's going to get me that invoice. Because unless I put a max age, I don't know, the cache doesn't know whether it should or shouldn't cache that. So I want to only get a new version of the invoice if there is a new version, if something has changed. And that's what the e-tag is. E-tag is basically what it does is it creates a hash of a resource. And then it sends a request, and in the request it sends a header that says if modified since, or if modified, and then it sends the e-tag. This goes to the server. The server says, okay, this is the resource it wants. Let me calculate the hash for that resource. Match it to the one that's coming in the request. If it's the same, then I send the 302 not modified. If it's not the same, I send back the entire resource, right? So what that is doing is allowing us to use caching that is dependent on the change of state of a specific resource, as opposed to a time. And that could save in performance because what we're doing is not having to get back something that might not be changing over and over again. Okay? And I'll show you basically e-tag interceptor. So again, you see I try and do this always, sorry, 304, not 302, always automate it. So here, for example, what I do is when a request comes in for a resource, I automatically check to see if there's a if non-match, which is the e-tag. The first time the request comes in, the non-match is empty, right? So then I calculate it, and then I send it back. The next time the browser makes a request, the client makes a request, it sends that e-tag value. I do a compare. If it hasn't changed, I send back the 302, 304 not modified. If not, then I let the interceptor go on and do what it has to do to send back the object. Okay?
One question about the e-tags and calculation. Do you promote the style that you compute e-tags before the actual content getting, or you compute e-tags just to reduce network load?
Well, you see, this is beautiful because I could completely say it depends, right? Because guess what? It does depend. It does depend on if the resource in question is something that could be modified many times versus what is the computational cost to calculate this and store this, for instance, right? So really it does depend on the frequency of what they're doing, and there is no safe thing, right? And again, this is good because it keeps consultants in business, right? If everything could be done with framework, we would all be out of a job. Okay, Hateos. How many of you know what Hateos is? Okay, this is really interesting because if you're doing a RESTful API, you better know what Hateos is. And that was like half of the room that were doing RESTful APIs. I'm just saying. No hate, but I'm just saying. Hateos stands for Hypermedia as the engine of application state. Fantastic, right? Hypermedia. What's this? Amazon Kindle, right, Amazon. Amazon is a website where you can go and buy stuff. You all know that. When I did this presentation 15 years ago, nobody knew what Amazon was, that's why. Joking. So, anyway, how many of you use Amazon? Okay, or the equivalent in Russia. What's the equivalent in Russia of Amazon? What? Boson. Ozon. Okay, how many of you use Ozon? Everyone. Right. How many times does Ozon send you updates about them changing their API? I mean their website. Do they say, oh, look, we've moved the checkout on the left? Never. I've never been contacted by Amazon to say, listen, next time you come to the site, your basket is top right. Okay? Next time you come to the site, you first have to add something. Then when you add that thing, then you've got to go and click this. I've never been informed of this. Why? Because I go to the website and I see it every single time. And when there's a change, I go to the website and my brain sees it. Right? Now, I go, I do my checkout. I add something to the shopping cart, I click on a link. And that link takes me to the next stage. Right? It's taking me through the process. It's taking me through the state of the application. And there we go. Hypermedia as the engine of application state. So what I'm doing is basically using links to take me from point A to point B, and then to point C. Right? And I'm doing that via discoverable user interface, which is the web application. So here's an example of Hypermedia. Here I do post domain.com/order. So I'm creating a new resource. I'm sending back a 201 created. I'm sending back a location header, which is telling me where that resource is. I'm sending back an allow, which is telling me what I can now do. So I've already created a somewhat discoverable API, because I'm not only saying you created a resource successfully, here's the URL for it, and here's what you can do. You can now get this resource, or you can put it. That means I can update this resource. But I'm also sending back some XML. And in that XML, I'm sending back some links. And I'm saying that that link basically is the next step. I can now go and order something. So effectively, what I'm doing is just using Hypermedia to drive the state of the API. Right? So what I'm doing is pushing the state from the server to the client. Now the client is aware of where it can go next. Okay? How can I do this? Well, I can use XML or microformats, or use atoms, or existing format :s atoms. Custom formats. I can create my own content type, which is application/VND, which stands for vendor /company/domain or domain plus XML. Can I use JSON? Of course, except JSON doesn't have links. There is no link in JSON, right? Now, there are attempts to make links in JSON, like _link. It's the same as what people use in JavaScript to create private fields. They underscore them. And then they ask, why don't you like JavaScript? HAL, Hypermedia, these are kind of like standards, and the best thing about these standards is that there's so many standards that, you know, there is now a standard to try and standardize all of the different standards, as that XSCD comic goes. So there's different versions. There is nobody in their right mind that can say to you, if you're using JSON, you're not doing Hypermedia. If you're using XML, you are doing Hypermedia or not. The only difference is that with XML or HTML, there is a semantic around what links are. With JSON, there isn't. You want to use JSON, go right ahead. But the people that you are communicating with, that are talking to your API, need to know about that semantic meaning of your links, of your media format that you're using. But the idea here is that what I'm doing, the most important thing here is that I am actually saying what state to go to next on the server. Sorry, pushing it from the server to the client. And what this means is that I don't need to have any more state on the server. Because every request comes back with Hypermedia links that says this is where you can go next. I don't need to maintain anything on the server. Okay? So the state is pushed to the client. Server cannot maintain state. What about cookies? Well, cookies are bad anyway because all of the sites now have that EU warning. But cookies are fine, except you can't keep state. If you keep state, then you're not leveraging one of the benefits of that. But it's okay. I'll come back to this in a moment. So what we've basically built up so far really is I've created something that is more discoverable. I'm using HTTP application protocol to create something more discoverable by simply leveraging a couple of the headers that HTTP provides me. I've moved away from actions, calculate age, to resources. I've moved away from creating my own operations to using the constraints on verbs. I've moved away from moved into creating multiple representations of the same resource. And I can add that aspect, which is hypermedia, to know the next steps. Known entities. This is fantastic, you say. Okay, I have an invoice, I can create an invoice. I have a customer, I can create, read, delete, update a customer. But we all know that actions aren't limited to 4 operations, which is going back to that little star that I put. How do I do something like, for example, ship order? So someone makes an order and I say ship the order.
Resource, order shipping.
Order shipping. Think of things in resources. Instead of thinking of them in verbs, instead of having an action which is ship order, think of it as a resource, order shipment. And when a shipment is ordered, when an order is shipped, I create a order shipment resource, which can respond with specific codes. And when I want to cancel a shipment, I can do a delete on a order shipment resource. Right? So obviously, not everything is going to be encapsulated in those four words. Versioning. Which one of these is the correct RESTful versioning?
Number one. This is not correct.
There is no correct versioning. Right? There is no. But some person out there that is a JavaScript hipster will write a blog post that says, this is how you do RESTful versioning. And you just say no. There is no correct versioning. What is the best form of versioning? Backwards compatibility. Yeah, what are you kidding me? I'm going to create backward compatibility. Yes, if you want to be a good citizen of the world, you have to create backwards compatible code, just like you do in your normal API. You put a little obsolete, but you keep it, and then in about 5 years you drop it. And then that one person that is using it will write somewhere and say, JetBrains doesn't keep backward compatibility. I'm not saying that this happened to us. Okay, maybe it did, but anyway. So, really, if you want to keep moving forward without having to keep versioning, you're going to have to keep backwards compatibility, which means ignore what's no longer relevant, but don't break. That's one of the key benefits of this. If I'm making a discoverable API, and then as soon as I change something, I make it completely incompatible, I might as well go back to WSDL and go to strongly typed clients that are creating proxies around my method calls to pass parameters. It's basically the same thing, instead of taking advantage of the idea of just let's make a discoverable API. And of course, if you don't want to do that, you can just do V1 or V2 or V3 or whatever you want. The best part about all this is there is no correct way. Let's talk security. No, let's not. Options. HTTPS, is it secure nowadays? I forgot. Did they hack SSL again or not? Even if they haven't, all the governments have access to us anyway, so it doesn't matter. And in the UK, they want to actually ban SSL. Anyway. Digest, OAuth, federated security, all of these things work. Like, there's nothing specific here. The only thing, like, do cookies work? Well, cookies work, except they maintain states around the login. But nowadays, you don't even use login cookies. You use tokens. Tokens is the way to go. So now, finally, let's talk REST. This is where we were at the very beginning. Plain old XML. This is called the Richardson maturity model, which is by a guy called Leonard Richardson, which I'll show you the book in a minute. And he defined this. This is where you become true REST. This is where you can praise the gods of REST, right? Okay, this is where Roy Fielding calls you and says, you did good, my son or my daughter. You did good, right? Roy Fielding is the one that came up with REST. So here is POX. which is plain old XML. Here is where I introduce resources. I now start to talk, instead of a single endpoint, I start to talk to multiple endpoints, each of them being resources. Here where I start to leverage HTTP verbs. Notice that nowhere here does it say pretty URLs and JSON, right? And at the very top, it's using Hypermedia. But these are basically constraints. That's all they are, right? It's just constraints. So what that means is that everything that I've told you about, you don't have to comply with. What Richardson says here is that if I comply with everything below here, well, what Roy Fielding says, that I use Hypermedia, I gain certain advantages. I can use the entire infrastructure that's out there of the World Wide Web, of proxies, of caches that all follow certain rules and use that for my transport, for my application protocol thing. If I say I don't want to make my verbs idempotent, fine, no one's going to kill you. But then you know that you might run into some issues with certain proxy servers, for instance. If you say I don't want to use resources, I want to have a single endpoint, fine, do it. But then you won't leverage some of the aspects of discoverability. There is no right or wrong way, right? It's just if you follow certain constraints, you get certain benefits. If you don't follow these constraints, you don't get benefits. If you want to call your RESTful API REST, you got to follow these constraints, and then you get certain benefits. The problem is that when you create an API which is not RESTful and you don't get any benefits out of it, and then you say REST, that's just a buzzword. So HTTP API is your application interface. You can actually have an HTTP API that's not RESTful, and it's okay. It's really fine. There's a lot, because creating a RESTful API is not easy, and often it just doesn't pay off, right? It's not worth it. RESTful systems create certain benefits that when you abide by these, you get certain constraints, and when you abide by, you get certain benefits. That's simple. Okay? Recommended reading, RESTful Web Services, which is Leonard Richardson, and Rest in Peace, which also, I mean, Rest in Practice. Rest in Practice, which is by Jim Weber and Ian Robinson, the two guys that are now working on Neo4j. How many of you know Neo4j? Ironically, it doesn't have a RESTful API. But that's not, it's okay. Anyway, good. Thank you. No questions. Great. Let's move on to the next one. Any questions? No. Right. Let's take a 5-minute break. You can go eat cold pizza, have a drink, go to the loo, and we'll be back.